Hi, welcome to the Onasphere Planet Tech demo. I'm going to show you how the planets are generated and how they impact the game. Okay, so first thing I want to show you is this is the default icosphere that gets generated by the planet generator. As you can see, it's made up of triangles and it's a little bit boring. So what we want to do is go ahead and enable the debug menu. We're going to go in and first thing we're going to do is play with the number of subdivisions in the icosphere. This has a pretty immediate impact on the way this looks. And if we bring that down to something very low, like 2, you can see here it's quite rough, very low triangle subdivision. And we can bring this really high, and you can see here that we have a lot of triangles that make up the sphere. Because there's a limit of 65,000 vertices per mesh in Unity, I've had to break it up into multiple meshes, which you can see here. So I'm going to go ahead and turn that back down to something a little more manageable just to show you the other features. So the next thing I want to talk about is the way that the colors work. So right now, it's pretty simple coloring. And the way this works is there's a triangle coloring and a hex coloring, and I'll get into those a little bit more later. But right now what I wanted to show you is the way that the hex coloring works. So as you can see here, it's a pretty interesting pattern that gets made. And the way this works is I pick a point. I think you can see right here. This one right here. And that's my starting point, which is actually a pentagon, not a hexagon. But I want to color it into hexes, because I think hexes look a little bit nicer than just random triangle coloring. So what I do is I pick my starting point, and then I travel in concentric circles around there. And in this case, I use the color to show which hex number I'm on, and it's just a gradient that increases over time. And you can see that it produces these patterns going around the planet where it gets progressively lighter until it gets to the endpoint right here. So what that allows me to do is fun things like random hex coloring, which is a great debug tool. So here you can see the way that the planet is divided up into hexes. Now, an icosphere is not a perfect sphere of hexes, because that's not possible. There's some references you could check out. If you look at Wikipedia, it'll explain why. But it's basically a set of hexes and a set of pentagons. So here's one pentagon with the surrounding hexes. And if we go over, we'll find another pentagon right there. So what you can see here is that I've got even coverage of the entire planet with hexes, and this will allow me to do some fun things later with the colors. So we still have a simple sphere, which isn't a lot of fun, and what we want to do is we want to add some noise to it. So I've got a couple of different noise functions, simplex noise, Perlin noise, and then a package you can get online called coherent noise, and I'm not really using that one too much, but it's still in there for testing. I rely mostly on the simplex noise because I like the way it looks. So what I have here is I have a couple of sliders that that show you how the noise functions are working. And I'll go ahead and turn this back to more regular colors because it's a bit hard to see otherwise. So what I can do now is increase the scale of the noise, and you can start to see the planet deforming. You can see here when I grab my mesh, it's pretty deformed with some noise. And what I'm doing there is I'm applying for every vertice on the mesh a noise function. So these noise functions generate an offset to the vertices that either suck it into the planet or push it away from the planet center. So what you can do now, now that you have a certain amount of scale on there, you can apply a cutoff. And what that'll do is it'll just add a bit of sphere back into the noise, so it'll round out things a little bit. You can also change the octave of the noise, and that makes it rougher or smoother. So a very low octave number means very smooth, low noise. And the higher the octave, the rougher the noise pattern will be. So here you can see it's a little more chaotic. Again, this is all stuff that you can read up about on Wikipedia. There's a whole bunch of great references on how noise works. Then there's the density, which adds a certain amount of chaos to the surface. And so the greater the density, the more chaotic it becomes, until finally it just becomes sort of a a crystalline structure, which looks pretty crazy. So you generally want to have this a bit lower for something, you know, a little more planet-like or asteroid-like, but I am going to play around with the idea of sort of crystal planets that have very chaotic structures. And then you can play with the scale, which obviously just adds more scale to the noise. So if there's no scale, it's a perfect sphere, and then the more you increase the scale, the more the noise gets pronounced. And once you have something that looks, you know, kind of good that you like, then you can go ahead and just hit the generate seed button. It'll just produce all kinds of variations with different starting seeds. So the next thing I wanted to show you is just the normal blending. When you're working with low poly stuff, you really want the faces to stand out more than the overall shape of the object. So what I've got is got a slider down here called normal blend, and that'll just blend the normals of the faces between something that's perpendicular to the face to something that's more in line with the vertex direction. If I crank that up, you'll see it get smoother, and when I crank it down, you'll see it get a lot more angular. There is, as you'll notice, a bit of variation in the overall color, triangle coloring, and that's just because things look a little bit better when you offset the colors of the triangles a little bit from one to each other. So you don't want something that's perfectly smooth, you don't want something that's too angular. I find something in the middle kind of looks pretty good. So next thing we're going to do is we're going to go ahead and look at a different preset. So I've got a couple of different presets, and I'm going to load up the asteroid preset. So here's something that kind of looks like an asteroid. It's a bit round, a bit chunky, kind of potato looking. It makes for a nice planet to play on, a good play surface. So what I've done here is there's just basically a scale factor that gets applied. Up here you can see an X, Y, Z scale, which applies to the planet. So I'm just stretching it a bit in the Z, and that's all that I'm really doing there. You can also see that I'm generating a collision mesh. As you can see, the green around the mesh there. And what that's doing is it gives a nice play surface that conforms to the surface of the planet. I can also use just a generic sphere collider with the planet as well if I want to do that. And the collision subdivision is down here. Okay, so the next one we're going to look at is we're going to look at a simple planet. And so that is here. And this one looks a bit different. It's got water, it's got color, it's got some nice noise functions. So the way I break the meshes down here is I break down the meshes based on color. I originally had this set up so that vertex color is how the planet got defined, but I thought that it would, you know, since I'm breaking it up anyway at the 65,000 vert limit, I would go ahead and break it up by color. So here you can see I've got a separate mesh there. There's the water mesh. So it's kind of nice. You can see the collision volume around it kind of conforming to the terrain, and I kind of soften the collision volume a bit as well so that it doesn't, it's not too angular for the play surface. So what I wanted to do now is I wanted to show the difference between the hex coloring and the triangle coloring. Right now we're using hex coloring, and as you can see here, it makes for a nice kind of even looking mountain top. Or in the editor window here, you can see this little valley and a little mountain here. Here's a little bit of snow cap. And I'm going to go ahead and turn that up to triangle coloring. And so now you can see where it's coloring it just based on the height of the triangle and not the height of the hex. You can see these sort of aberrations poking out here, little one-off triangles and funny things. These peaks don't look as nice as they do when it's on the hex coloring. So that's just a bit of an optimization I had to do just on the visuals to make it look a little bit better. This ocean looks very chaotic now with the triangle coloring, and in hex coloring it's more jagged but a little more regular with the hexes. The next thing I'm just going to show you is the water. So I've got some water sliders down here as well, and you can see the water just kind of has a general undulation to it to make it sort of look oceany, and that's basically just done with the frequency slider down here and the scale slider down here. So I'm taking a sine wave function and just applying it to the entire mesh. The water mesh is right here, so you can see the mesh deforming in real time. So if I change the frequency, it changes. Let me just turn off these static meshes here. And so then you can see the water. So when there's very low frequency, it just follows a generic sine wave. And when I start to add a little more frequency to it, you can see the ripples kind of flowing through the sphere. You can see them flowing through there. The scale obviously just scales it, so you can kind of get very crazy looking things if you have a very high scale. Generally you want a very small scale, because when you turn on the rest of the mesh, you don't want the water to be flying through like that. You want a very low scale with subtle movement so that it doesn't, it's not too distracting. So then the final thing I wanted to show here is just something that I added recently, and that's just random color generation. And I thought that since the planets are all procedurally generated, it'd be fun if the colors were procedurally generated as well. And I've gone ahead and added some random color generation based on color theory. So there is monochromatic colors, adjacent colors, triadic and quadratic colors, and then just random colors. So if I go ahead and pick a monocolor, you can see that it's generated a new planet with all, turn the water down a little bit. In fact, I'm going to turn it right off so you can see the planet better. So you can see this is just a monochromatic color, and when I go through a few of these variations, you get some interesting planets, some interesting things happening there. When I go to the adjacent colors, you can get sort of complementary, kind of similar colors happening. It's not monochromatic, but it's not too ugly either, I don't think, at least. Triadic colors, where things get a little more interesting, start getting a little more interesting choices of colors, and I think this kind of looks the best for the planets. They definitely look quite alien. And then the quad colors are starting to feel a little more chaotic, a little crazier. And then random colors is where you get some really weird things happening. But still lots of fun. Okay, and then the last thing I wanted to show you is I've been working on some tech for the gas planet generation, which is something that I have wanted to add, but just never really got around to it. And I'm just sort of playing around with it now. So what I find looks good for a gas planet is you kind of want to have a big round sphere like that. And then what you want to do is the coloring based on height map, based on noise, doesn't really work anymore because you don't have that kind of a color. So what you want to do, you want to go into gas planet mode. And so what this does is it takes the same map of colors and then maps them sort of up and down into stripes on a gas planet. And then now this is where you can start doing things like these colors into sort of gas planets. I'm still playing around with it, and with it's still all based on hexes. So maybe this would work better with triangles. I don't know. Still playing around with the gas planets right now just to see what works and what doesn't work. A few more random choices here. So anyway, that is a quick look at the tech for the planet generation in Onasphere. And I'm going to write up a little blog post as well to accompany this, which covers maybe a little more code or a little some snippets here and there just to see how things are actually working. Anyway, I hope you enjoyed it, and subscribe to Onasphere Twitter, or you can check us out on Reddit or our webpage, www.onasphere.com. And we'll see you again next time. Thank you.